Hi there, welcome to this video on web services architectures and patterns, and we will be looking at REST and SOAP web services, and we'll be looking at the frameworks in the Java world. This is the third video in the series of videos where we are looking at multiple architectures and patterns, the evolution over a period of time. We started with looking at the big picture, and in the last video we looked at web application architectures in depth. And in this video, let's look at web services architectures in depth. So, why do we need a web service? That's the first question that we would need to answer, right? So, when we talk about a web application, right? So, I have a web application. Where do you consume a web application from? You typically consume it from a browser, right? So, you'd launch up google.com on a browser. So, from a browser, you try and access the web app, and the web application would send a response back. So this is a request which is sent, and you'd send a response back. Now, what if I don't want a browser to talk to the web application, but I would want another application to talk to the web application? So let's say I have application 1 which wants to talk to another application which is application 2. So these two applications want to be able to talk to each other. How can we enable that? That's where the concept of web services comes into picture. Now, think about this web application that we have built. Let's say this is a Java web application. So the output of this is a WAR file, or like in the olden days we used to use WAR. Maybe these days you might actually have a jar file which is deployed. This web application, let's say some other application wants to consume some business logic which is present in this web app. How can I do that? One of the options is I can take the business logic and create a jar for it. So I can take the business logic, create a jar for it, and give it to the other application. But is that a good solution? Nope, right? One thing is there is a lot of manual effort. Every time there is a change in the code, you need to create a new jar, distribute it, and all that stuff. And also the other application needs to be updated and released. Now, the second problem is that this is a Java specific solution, right? So if let's say the application which wants to consume this code, or which wants to reuse this logic, is let's say a Python application, a Node.js application, then it cannot make use of the jar at all. You have to build it again. And that's the reason why you would want to create a web service. So instead of asking the other application to use a jar, what we would do is we would create a service, a web service around your logic. So you have your business logic. I mean, this can be Java code, this can be Python code, or any such kind of thing. What we would do is this app 2 would expose a service, a web service around your business logic. So the whole thing which is present in here is a web service. The important characteristics of a web service. So let's say I'm calling something a web service. So this is a web service. What are the characteristics that it would need to satisfy? Number one is a web service enables machine to machine interaction. It allows communication between applications. The end user of a web service is typically another application. I mean, you can manually call the web service and see what the response is coming back, but typically the consumer, the end user of a web service is another application. The other important part of a web service is it's interoperable. That means it is platform independent. It does not matter whether you are deploying this web service on Windows, Unix, Linux, wherever you are deploying it, it should be able to work with another application which is deployed in some other platform. And the same way, it is language neutral. What do we mean by language neutral? Language neutral is the web service might be built in Python, it might actually be built in Java, whichever language it's been built in, it should be able to talk to other web services. You should be able to provide services to other applications developed in other languages. So we talked about machine to machine communication, we talked about interoperability in terms of interoperable in terms of platforms and in terms of being language neutral. And typically all the web services talk over a network. So typically one web service might be deployed on another machine and the other one might be deployed on somewhere else. So these web services should be able to communicate over a network. So these are the important characteristics of any web service. Now we talked about the characteristics of web services, right? So what are the typical formats in which web services interact? The typical formats of web services are SOAP and REST. Let's start with SOAP. So very early in the piece, as soon as web services started becoming normal, the architecture which was prevalent at that particular point in time was service oriented architecture, SOA. These typically like the things which were present in service oriented architecture, the applications had a centralized bus and all the communication which was happening there was based on XML and SOAP. SOAP stands for Simple Object Access Protocol. When you are creating web services using SOAP, what you do is you would have the request and the response. So if this is exposing a SOAP service, then the request format is XML and the response format is also XML. And we use something called a WSDL, Web Service Definition Language, to define what is the format of the request, what are the headers allowed, what is the format of the response, what are the headers which would be present in the response. All those things are defined using a WSDL. This is also called a contract or a service definition. A service definition provides how you can actually interact with that specific service. What is the request, what is the response, and all that stuff is part of your service definition. In SOAP, typically we use something called a contract first approach. What is a contract first approach? Where you would actually define the contract first. So you define the request format, the response format, and then you would actually build the business logic or the application to provide that particular service. The other alternative is code first. Typically whenever we talk about REST, we would see that you would go for code first. But it's not really mandatory. I mean, it's not that all REST services use code first, but most of the REST APIs typically use code first. The problem with the SOAP web services was there is a lot of ceremony. Creating the WSDL was very, very tough. I mean, it takes a lot of time for you to really create a good WSDL, agree on a contract, and all that fun stuff. Now, looking at the frameworks which were used for developing SOAP web services, the most famous frameworks for developing SOAP web services in the Java world were a framework called CXF. There was something called Apache Access, which was also quite popular. And over a period of time, as usual, the Spring framework came up with a Spring web service framework, and that became kind of the norm in the web service world. There is also a Java standard called JAX WS. I mean, this is a Java EE standard or JEE standard as it was called at that particular time. Java API for XML web services. So all these were the popular ways in Java to develop SOAP web services earlier. I am really comfortable with Spring web services. The great thing about Spring web services is that it enforces a contract first approach, and that's why I love developing SOAP web services with Spring web service. Now that's SOAP, right? SOAP is all about the standards. So SOAP is all about WSDL, enforcing a proper contract, having a defined structure, and having a communication between two applications using that defined structure. REST stands for representational state transfer. So representational state transfer. That's what REST stands for. Actually, I shouldn't say REST and SOAP are competing styles. SOAP defines a specific format. REST actually is more of an architectural style. It defines a few constraints. What are the constraints that REST defines? REST says you should have a client server architecture. So you should have a client which is consuming your service, and there should be a server which is producing your service. That's kind of the normal, right? And the other important constraint that REST provides is you should offer a uniform interface around your resources. So in REST, you treat everything in your application as a resource, and you are expected to provide a uniform interface, a uniform way to access all your resources. The other important constraints that REST places is that your services should be stateless, right? Typically web applications have sessions. So in the session you would store some information about the currently logged in user. But with REST, you are not allowed to have any state. Your services should be stateless. And your service responses should be cacheable. I mean, you don't really need to hit the server every time. You should be able to cache the requests some of the times. The other constraint REST places is that it should be a layered architecture. So you should assume that the request actually goes over the network and there are multiple layers which are involved. So these are typically the constraints which are posed by REST. If you look at REST, a lot of projects implement REST, but how do you decide which of them is implementing REST very well? That's where there is something called Richardson maturity model. So Richardson maturity model helps us to identify which REST implementations are good and which REST implementations are not really good. So there are multiple levels: 0, 1, 2 and 3. The 0 is basically a SOAP style REST. So just do whatever you are doing in the SOAP style thing. However, use JSON or use your specific formats. So level 0 is nothing but your REST in SOAP style. So you just say, okay, delete course, add course and all that kind of fun stuff. Level 1 is all about having proper resources with proper URIs. So you would create a resource called /course/1. So you would have a proper URI which is associated with your resource. You would have a student resource, you would have a course resource, you would have proper resources which are defined, and you would have URIs for all of them. Level 2 is about level 1 plus making sure that you're using the HTTP verbs. So what are these HTTP verbs? Typically whenever we talk about HTTP is how your browser and the internet work, right? So when browser interacts with a web application, it sends a HTTP request, and the response coming back is a HTTP response. And typically the HTTP verbs are get, put, post, delete. So these are all called HTTP verbs. Level 2 of Richardson maturity model is level 1, creating resources with URIs plus making sure that you are using the HTTP verbs. So if you want to delete a course, you would send a request to delete courses/1. If you want to update a course, you would use either put or post. If you want to get the details of a course, you would use a get request. Level 3 is all about HETEOS, hypermedia as the engine of application state. So that's what level 3 is all about. It's all about just to make your REST like a web page, right? So whenever we have a web application, if you look at the page, what does it have? It will have all the data here, but it will also have other things you can do with the data. So you'll have a few buttons which you will have in here which you can use to play with the data, delete, edit and do all that stuff. And also you would have other links which are present in here which will help us to do other actions, other high level actions with that specific resource which we are viewing at that particular point in time. And HETEOS is all about taking that to your REST APIs, not just returning a response with the data back, but also the response should contain the actions. So response should contain data plus actions that you can perform with that particular data. So that's what HETEOS is all about. Richardson maturity model identifies which level you are in. So if you have a REST API which is being exposed, you can look at the REST API and see, okay, I'm level 2, I'm level 3, level 4, level 5 and all that stuff. As you can see until now, REST is all about architectural style. It places a few constraints. There is a way you can evaluate your REST implementation. REST does not say you have to use XML. REST does not say you have to use JSON. The format, the data transfer format does not really matter as long as you are adhering to all these constraints. Now, let's look at the frameworks aspect, right? So now we would want to look at the frameworks related to REST. Java standard is JAX RS. So Java API for RESTful services. That's the standard, and the standard implementation for this is Jersey. Other than that, there are other popular frameworks just like Spring MVC, or it's also called Spring REST. Actually, Spring MVC and Spring REST are exactly the same thing. The same framework which supports building web application also supports building REST APIs. Now, the other framework which is now popular to develop REST API is Spring Boot. Spring Boot is nothing but a layer on top of Spring MVC. It makes it easy to get started, quickly started with building your REST APIs without worrying about all the configuration that is needed. So if you add a framework in, if you add Spring MVC framework in, Spring Boot, make sure that it's configured and ready. If you add Hibernate in, it configures a data source. It configures, if you have, if you want to use an in-memory database, it would configure that. If you want to connect to a real database, if you have the driver put in your class path in the pom.xml, Spring Boot would automatically configure a data source for you. Let's now look at some of the best practices which are related to RESTful API. So we are doing a lot of stuff around the RESTful API. So the place which we have in here is not sufficient. So let's add best practices in here. So what are the best practices with respect to REST API? Some of the best practices for me are actually things which are applicable for any API you build, right? So you should always think about your consumer. So the first thing is consumer first. So you should always think about your consumer while building an API. What are his needs? How does he understand it? What are the resources he will be able to understand? Am I naming my resources properly? Always think from the perspective of a consumer, from somebody who's looking at from the outside in, and see that you are providing the best possible service definition from his perspective. Also make sure that you have proper documentation made available to the consumer so that you would be able to provide great services. So typically when it comes to REST, the popular format for having documentation is Swagger, and now Swagger is called Open API documentation. So Open API documentation is one of the best formats to expose your service documentation when it comes to REST. The other important things when it comes to REST is obviously you have to make the best use of HTTP. Use HTTP resources and use HTTP verbs properly. Send a proper response back in, and also send a proper response code back. So if you are sending a proper response, successful response 200. If you are sending a page not found or a resource not found, 404. If there is a server error, 500. So if a resource is properly created, send a response back of 201. So use the proper response code, use HTTP properly. That's the second best practice which when it comes to REST. The third important thing is to have proper enterprise level standards. If you look at REST, how you name your resources, how you do your documentation, how you do your HETIOS, how you implement versioning, whether you're using URL versioning, whether you're using versioning based on content negotiation, whether you're using header based versioning, all these need to be properly documented, and it should be consistent across your enterprise, which you can use any of the versioning approaches, but make sure that it's consistent across your enterprise, and that's very, very important. So you should have standards across your enterprises, and also try and automate as much as possible. So documentation, the testing of REST API, try and have a lot of automation tests so that everything is proper. So in this video, we kind of looked at the big picture around web services. We talked about REST API, we talked about SOAP web services, we talked about all the frameworks in the Java landscape that are used to build REST API and SOAP. We talked about the how you build a SOAP service, we talked about how you have REST APIs built, and we also talked about Richardson maturity model and the best practices related to REST. This is the third video in our series of videos on Java architecture evolution, where we are discussing starting from web application to web service. In next videos, we will talk about microservices, cloud, and also maybe multi-cloud, Docker, and Kubernetes. In this video, we talked a lot about web service. Check out the playlist which is present in the description of the video for more information about the other videos that are part of this series. If you like the video, make sure that you like this and subscribe. And also, I would place a few links in the description of the video on how you can actually create a REST API with Spring Boot, and also how you can create a SOAP web service with Spring Boot. Do look at them if you want to go and build something on your own. One of the frequently asked questions for us is, how do I become a full stack developer? How do I become a microservices developer? How do I learn the cloud? How do I become an expert on AWS? The amazing thing is we have learning paths built for each of these, and these learning paths contain what are the skills you would need, what is the learning path, how can you start, what can you do next, what can you do everything to achieve your goal. And also these learning paths contain videos and course recommendations with these things. You can find a link to these learning paths in the description of this particular video, and you can check out whichever learning path you would want. For example, the learning path 05 is the one which makes you an expert on AWS. So it has the recommended skills, it has the prerequisite skills, it has the recommended course path, and also it has recommended preview courses. These are free courses you can do, and also it has links to the other learning paths as well. We recommend you to make the best use of these learning paths to make sure that you stay ahead of the curve. Keep learning in 28 minutes. Until the next video, bye-bye.